Well, welcome to another DevNation Live. I'm excited to have all you guys here today. We're going to have a lot of fun. You can see I'm trying a new camera setup, so we'll see how well this holds up. It might actually fall apart on us midstream. But I'm not the star of the show today. Today we have Gunnar and Matthias, who are experts in all this stuff called Kafka, Knative, Debezium, Kubernetes, and everything you're about to see in this one session. It is going to be a ton of fun, and I think you're really going to enjoy it. As always, throw your questions into the YouTube chat. I'll pick them up from there and relay them onto our presenters. And also, I'll be passing links through the YouTube chat, so be ready for that. You know, we'll have the demo links. And the number one question, by the way, is where are the slides? That'll be on the link you're on right now. So just be prepared for that, so you know what URL you're at. Always, you can email me. You probably received an email from me this morning announcing this session as well as our future sessions. If you have ideas for other things you'd like us to do on DevNation, please let me know. I'll be happy to try to those things out as we schedule more of these events over time. Do look for more master courses next week. We took this week off, but next week we come back with more Kubernetes intro content. And then you're going to see more things scheduled after that, including a Kafka master course and some more content for our operators and operations teams, everything coming in the future. But right now, I want to turn it over to Gunnar and Matthias. I think Matthias is up first. Matthias.
Hello. You see Gunnar's slides already? Hello, welcome. So this is another DevNation live session. Today we have a little content program here, some very interesting use case that leverages a few interesting aspects of modern application development. We're going to see how you can actually achieve serverless stream processing using Debezium and its change data event facility in combination with Knative. And behind the scenes, we will also see something about Apache Kafka usage in this setup. Today we are here, Gunnar Morling and myself, Matthias Wessendorf. We are both principal software engineers at Red Hat. Now on the next slide, Gunnar is explaining you today's objective and the solution.
All right. So hello everybody. Welcome to this DevNation session. I'm super excited to be here. Thanks, Bert, for having us. So, we thought we wanted to talk about some technology we have here, like Debezium and, our Kafka offering, Knative, and so on. But then we thought, let's drive it from a use case perspective, right? So we set out a scenario and we'll see how we can address this with the technology at our hands. And the idea is, so the objective for the talk is, we would like to consume a stream of temperature measurements. So we have like a network of temperature sensors. It's a fake network, right? But we have a stream of temperature measurements which are coming in via Kafka. We would like to enrich this stream with master data, which is coming from a database. So like what's the name of the sensor or the station where it's coming from, like the spatial coordinates and so on. And this is fed to Kafka via Debezium. So we would like to enrich the temperature measurements with this master data. Then we would route this enriched stream to different consumers. So we'll see how we can do this using Knative. And finally, we always like to see some visual contents, right? So we will show how we can take those values and show them on a map of the world. So we put all our efforts into building this awesome visual representation of the data. So let's take a look at what we have planned here. Hold on. You see the first part of the solution overview, right? That's what you see?
Yes.
Is that right? All right, excellent. So let's go back. So this is the overall solution here, and there's quite a few parts of that, right? So we have Debezium, Kafka Connect, and so on. So let's break it a bit down and get go through this in steps one by one. So the first thing is this measurements they are coming in, right? So we have like a fake source of temperature measurements, and they're sent into a Apache Kafka topic. So we have Kafka running there, but we would like to enrich this data with the master data from a database, right? So we have a Postgres database. This contains the master data of our weather measurement stations, and we use Debezium, the change data capture tool, to go to the database, tap into the transaction log, and capture the contents of those master data table there, and send it into another topic into Kafka. So we have two topics in Kafka, and this Debezium, it's running in Kafka Connect. So that's another runtime which is part of Kafka for operating those connectors. And in order to run all this, we have set up Strimzi. So Strimzi is a Kubernetes operator which allows us to run and operate Kafka and Kafka Connect and all the surrounding things very easily on Kubernetes or OpenShift. So we will talk about that a little bit. And then, but we would like to process those streams, and this is where Kafka Streams is coming in. So that's an API which allows us to take data from Kafka topics, join those topics, enrich the data, maybe aggregate data, group data, filter data, map data, and so on. So we use Kafka Streams, and as the runtime for that, so that's a Java-based API. As the runtime for that, we use Quarkus. So, I mean, on DevNation, you've seen about Quarkus definitely before. And so that's our cloud-native stack for implementing applications. And it also has a support for Kafka Streams, which allows us to build those streaming applications, for instance, for the JVM and also for the GraalVM native code. So we have that, and it will process those two topics. I will tell a bit about it, and write the enriched data back into another Kafka topic. So we have this enriched temperature data there in Kafka. And then we put data to Kubernetes, or sorry, to Knative, and this is what Matthias can explain a bit more about.
That's right. Until the previous slide, we had a regular stream processing application that was also running inside the cluster, transforming the data and enriching them. And now the scenario that we would like to show is how you can use components like Knative to actually offer a serverless deployment, and that you have some services up and running where you can query data that's sitting inside of your Apache Kafka. And for that, we use some components from the Knative organization. We have a Knative Kafka source there that basically reads this third topic that Gunnar was introducing, and our Kafka source is pumping all of the Kafka events that are there, is transforming them into cloud events, and is publishing that to a broker in Knative Eventing. And on the next slide, what we see here is that we can now apply some trigger, that's the API call in Knative, which basically is a filter, and you can filter based on the metadata of the cloud event. You can then distribute it across different services. And what we have here is, in our demo use case, we have an application that's also written with Quarkus. That's an HTTP web server receiving all of the cloud events and is putting them into a WebSocket server and also providing you some nice little UI. You see the graphical card there with the temperature sensors. And then through WebSocket, you will basically see an interactive UI where all the measurements of the different weather stations are. And then on the next slide, it gives you the entire overview that all of these components that we have here running are all running inside of the inside of the Kubernetes cluster. Oops.
Sorry about that.
Yeah. So you see the border with the Kubernetes cluster. So everything is running inside that, except for the user browsing the URL in his favorite browser. And on the next slide, Gunnar is saying a little bit about the solution elements, and then we go to the demo.
Right. So, and we were talking about it briefly. So we have Debezium in there, right? So this is change data capture. It means we can capture all the changes out of databases like Postgres, which is what we are using here, or MySQL, SQL Server, and so on, and stream those change events into Kafka. So we have these events which describe like the old state of a row, the new state of a row, and so on. We have Strimzy for just running and operating Kafka on Kubernetes. So this makes it very easy for us to interact with the cluster, spin up new nodes, spin up Kafka Connect, and so on. We have Quarkus and Kafka Streams. We talked about that. And then finally, we have Knative, which allows us to scale out consumers based on the load, route those requests to different consumers, and so on. So those are the parts which we are having in this demo there. All right, so let me go and switch to the console here. So can you see my console?
Yes.
All right, excellent. So first of all, let me take a little look into this temperature measurements topic. So I'm using a tool called Kafka Cat, which is an awesome tool to just interact with Kafka topics and see what's in there. And I'm using this, and I'm just taking a look at the values. So they're coming in from our sensors, right? And it's just like tuples of a timestamp and a measurement value. And the message key, which we don't see here, that's the weather station ID. So we can identify the source of those measurements. So this is our Kafka topic. Now, I mentioned I would like to enrich this with the data coming from the database. So let's take a look into this database. And I'm using another cool tool, which is called PGCLI. And I can just take a look into my Postgres database here. So let's see. And I'm just having this table here, weather stations. So that's what I'm interested in. And well, this is just like the master data of this station, of those stations, right? So I have the name and ID. I have the coordinates where this is the station, and I have this active true false flag. So this is, allows me to enable or disable stations. So we will touch on that later on. And I have a few here in the database. Okay, so the data is there. Let me leave here. Now, the next thing to do is I need to set up Debezium, and I need to deploy a Debezium connector, which will get the changes from this table and send it into a Kafka topic. So for that, I'm using this Streamsy operator. So it not only has an operator which allows me to set up Kafka and Kafka Connect, there's also an operator which allows me to set up Kafka connectors. And this, I mean, if you've interacted with Kubernetes before, you will know it's done via custom resources and custom resource types. So there's one for connectors. So let's take a look. And I have this one here. So this essentially says, okay, this is a Kafka connector which I would like to deploy here. It has a name, and then I have a configuration there. And this is, well, just the configuration you would know from Kafka Connect and from Debezium. So I have the host name of the database. I have the credentials which I'm using to log in. I have this whitelist here, so I'm just interested in this particular schema, and like a few more things which are not too important for now. But this is like the regular connector configuration. So let me apply this. So I use kubectl. I say apply -f Debezium, and then my cluster lives in a different namespace. So I need to put it there. And it should say me, okay, I created this. So I can take a look now into this connector. So again, I say, I use kubectl. Now the nice thing is, as all those things are artifacts which are managed by Streamsy, I can just use kubectl to, explore the state and interact. So I can say get Kafka connector, and let's just see what's there. So there's the one I created, so we can inspect it a bit more in detail. So I say inventory connector, and I put it out into JSON. And just to make it a bit nicer, I pipe it to JQ. So here I see my connector, and I have the configuration here. And I see also the status coming from the REST API of Kafka Connect. So it's running. That's awesome. So now let me take a look into the Kafka topics which exist. So Kafka topics are also managed here. So let's say kubectl get Kafka topic and Kafka. And there should now be a topic for our weather station. So the connector created what we call an initial snapshot of this data. So let's take a look there. Let's see. I have this here. Kafka cat, I'm using that again. And now in this case, I would like to see this topic from the beginning because, well, no new events are arriving there as this is just the initial snapshot data. So let me take this, pasting this here. And let's see, let me pipe it to JQ again. So now here we see the data from the weather stations topic, right? And this is the Debezium event structure. So essentially here in the after state, I have like the new state of those rows. And in this case, I don't have the before state, well, because it's just the snapshot, right? So it's just the current state. But if I had an update event, then I would see both before and after. And then I have some more like metadata, like the source where this is coming from. All right, so I have this data in this topic. Now, the next thing is I would like to do this stream processing, right? So I would like to run Kafka Streams. So let me do that. And for that, I need to deploy another application, which I have prepared here. And let me do this first. So I just deployed this application, which is another Quarkus application. While it's deploying, I can take a look into the source code just very quickly. So I hope you can see my Eclipse there. So this is my IDE. And now with this Quarkus Kafka Streams extension, this gets very easy for me. So I just need to have a CDI producer method, which returns the topology of my stream application, really. And then, well, it takes care of managing it, right? So it awaits all those input topics which this application needs. It could expose things like metrics or health checks for me. So this really makes it easy to run those applications for me. And I could, for instance, also take this and run this application in the crawl VM native mode, right? So then it would be very efficient that I could scale it out in the cluster and so on. But let's take a look at the processing logic here. So essentially what I do is I have a K table. So this just gives me the current state of this weather station topic. And I filter it just on the active stations. So I'm just interested in those weather stations which are active. And then I built a stream, a K stream, and this is on this temperature values topic. And now whenever there's a new measurement coming in, the stream will produce a new value. I first map it. So this means in this case, I split up the values. If you remember this tuple of timestamp and value. So I split it up and I return it as a JSON representation, which makes it a bit easier to process downstream with the station ID, the timestamp value, and also an icon. So Matthias and I, we are both emoji lovers. So that's why we put in this icon here, right? Depending on the temperature. And this gets returned. And now I join it. So I join the K stream with the K table. based on the weather station ID, and then I take the station name and the coordinates from the weather station topic and this K table and put it into this join result. And finally, I group it and I aggregate it because I'm also interested in the average temperature measurement per station. So this is what this grouping and aggregation is doing here. And finally, I'm writing out this result of this processing application into another topic, right? And there's now many things more I could tell about Kafka Streams and the Quarkus extension, like its live coding mode and so on. But for now, that should be enough on that one. So now we can take another look into those topics. And there should be another topic, and indeed there it is. So this is temperature values enriched. So let's take a last look into that one. Kafka cat begin temperature values enriched. So let's just take a look there. So we see our stream processing application is doing something right. So I see now the transformed data, right? So I got from this little presentation, and now I have the station name in here, I have this average value in here, I have my icons in here, and everything else. So I have now the stream with enriched data, and then let's talk, or let's hand over to Matthias, and let's talk about how this now can be consumed in a Knative way.
All right, let me take over the screen.
Thanks.
And you should see my terminal here. So now that we have this application that's kind of self-contained with the stream processing, we want to kind of break out of the cluster and would like to have a web application that is accessible by everybody in the browser, and that they can have an interactive map where they can see all of the measurements that we have with a nice little location icons there as well. So for that, what we need first is we need some service that is a Knative serving service. And let's take a quick look at my code for this one here. So I'm now using a very simple YAML file. That's all you need to do for the deployment here. It's a service type for Knative serving, and very similar to vanilla services in Kubernetes. It has a specification, and you can define some image in there. And what I do here, I provide a container image that's basically representing Gunnar's map application that he wrote for this demo. At the end of the day, this is a web server listening on port 8080 HTTP, and this guy will get the cloud events posted in and will then store them in the WebSocket server. And also this guy contains the WebSocket UI where we can later see all of the measurements. However, I have already deployed this one, but you can see here my namespace. I don't have any map display application running here because there's no HTTP payload right now on this application. So Knative has scaled it to 0. And as soon as we stick all the pieces together, listening on data from Kafka and distributing it through the Knative broker to the consumer, then we will see this map display application will spin up. But first things first, let's take a look how we can actually access the Kafka topic that we have. So for that, I have a different YAML file that's part of the Knative project. It's a Kafka source. I have a little bit of metadata. This one might be interesting here. This label for Kafka sources has a key type because we have an integer. So the Kafka messages that are on the topic, they have a primary key, and it is an integer representing the station ID. And then inside of the specification, I'm just giving the location of my Kafka Bootstrap server that Strimzy has deployed me into the Kafka namespace here. And then I can provide a list of topics, like vanilla Kafka topics, that I would like to listen to. And the messages that you were seeing in the last Kafka cat session from Gunnar were actually already in this temperature values. So this Kafka source as a Knative construct will access the data that Gunnar's streaming application did create by using the two other Kafka topics, and the outcome was stored into temperature values enriched, and that's what we're going to be consuming. Now, I was saying already earlier what happens here inside of the Kafka source. So every event, like native binary Kafka event that is read there, is turned into a cloud event. And every cloud event is posted using HTTP to some endpoint that's referenced here as the sink. And in our case, I use the broker, the default broker of Knative Eventing, which is already running in my namespace here. So now let's apply this Kafka source. And in my namespace watcher here, what we see there is a Kafka source that's being created. These pods here, broker default ingress and broker default filter, is basically the pod that we need for our Knative broker to be around in your user namespace. So now we have the Kafka topic that is reading the data. However, it is just pushing the data to the broker, and we still do not see our Knative map application coming up here. That's because we have not yet applied a trigger or a filtering mechanism so that the broker actually knows, here is somebody interested in these kind of messages, and then we send them along a particular interested consumer. Let's take a look how this trigger API looks. I have a trigger here, and again, some metadata, like I gave it a name. And here inside of the specification, I have the more interesting parts. So I have a broker, and I go for the Knative default broker here, and then I have a little bit more opportunities to filter based on the metadata of my Cloud Event objects that are coming in. I have a filter based on the attributes, so every valid Cloud Event message does have a different type. And in our case, we are interested in listening for Kafka events that came from the Knative Kafka source. I could also do a little bit more filtering, that I'm only interested in the key attribute that's there, the extension for the weather station ID. So if I would comment this line out, I would get only weather stations from the station with the ID number 7. Now, when the filter is being applied, all of the matching messages, in this case only Kafka messages, are being sent to the subscriber, which is referenced here as a Knative serving service. And here we go. We have our map display. Now let me apply the filter or the trigger. Now once the controller does actually reconcile the filter, what we should see here, and we see it, there is a new container spinning up. It is the map display. So the Knative Eventing broker is now routing, based on my filter measurements, is now routing the HTTP payload of the cloud events, is routing them to my map display. And the Knative activator has noticed that and is activating it. And we have a very low number of messages, so we see only one pod. If we had thousands of messages coming in here in a millisecond, I would have seen much more map displays. Back in November, I was giving a demonstration on DevNation Live about Knative and Apache Kafka. And what I used there was a sample application which has a couple of 100,000 messages streaming all the way. And I was getting a lot of consumers there. Okay, cool. Now that this thing is online, let's see what it actually looks in the browser. Let me open the screen where I can, oops, I need to move it over, sorry. Second, I have a map that is now basically representing this application. I make it a little bit bigger. And what we see here is I'm connected to the WebSocket server that is enabled in this map display application. It also has the HTTP endpoint for receiving the cloud events. And the filtering mechanism is delivering all of the messages here, including the fancy emoji-based payload of the actual data. And what we have here is a few weather stations from Europe. And now Gunnar can take it on and enable a few more stations, right, Gunnar?
Right, exactly. So if you remember in my database table with the weather stations, I have the option to enable and disable stations, right? And so right now, just those few are enabled. And now all I need to do is in the database, I just can literally use my SQL. I say update weather stations set active equals true. So let me run this. And then we should see more values also from other stations coming in, right? So now we see Australia there, and it's like there's one from the US and so on. So now we see all those stations, and this is really a cool thing, right? So I just was listening to, or we are listening to those change events from the database, and now, well, Debezium captures this update there. So essentially, it puts the update event out to the Kafka topic. Our stream processing application, it will now put all those stations into this join because, well, none are filtered out anymore, right? So now we see the complete set of data here in the browser, right? So Matthias, you're on mute. Should I take over, or do you want to do it?
Oh, sorry. Yeah. I would like to conclude as a summary what we have seen in the demo here, recapturing the picture from the solution overview. So what we saw first there was some temperature values already in the Apache Kafka topic, and then we were importing data for weather stations from a Postgres database using Debezium and feeding that into one other topic. Then we used the Kafka Streams API to join those two and enrich them and store them in this enriched values topic. And from the enriched values topic, we were feeding this information into Knative. And with the API of the broker and its trigger or filter mechanics, we were actually able to route this based on specifying I'm interested in Kafka events. And then we were dispatching that to the Quarkus web application, receiving those events as HTTP, storing them in WebSocket. And with WebSocket, the user that's sitting outside of the cluster could basically see an interactive map where all of the current measures were occurring. That basically is a conclusion of our demo here. We have a few more materials around Debezium. We have a link here for Gunnar's repository where we stashed stuff. The last update was a little bit than an hour ago. And we have some more information about Debezium and as well as Red Hat OpenShift Serverless, which is the opportunity where you can install Knative serving and Knative eventing into your OpenShift cluster.
And maybe just to add one more thing, so I think all those technologies which we were covering here, like Debezium, Quarkus, and Streamsy, Knative, they all were covered in other dedicated DevNation talks before, right? So if you would like to learn more about any of those specific technologies, I definitely would recommend you go back to the archive and look at those sessions which tell you in more depth about the individual technologies.
That's right.
Yep.
And then we hand it back to Bert.
Well, that's actually a great point, Gunnar and Matthias. Thank you so much for that. Great point, because if you want more information on Streamsy and how to run Kafka on Kubernetes, we have dedicated sessions on that. We have Debezium sessions. We have Knative sessions. So many of these things you've seen before, but what I love is that you guys brought it together in a really amazing overall demo, right, where it's all together supporting a certain use case. That is super cool. We have a couple more minutes for questions. If anybody has a question, we'll wait a second for that to show up. There was one question about the were you using the Kafka Streams API or are you using Mutiny and the reactive APIs in your code bases?
Right. So no, this is actually using the Kafka Streams API as it's defined by the Kafka project. The way I see it, Mutiny and microprofile reactive messaging and Kafka Streams, they all nicely, combine and amend each other. So I would say, if you'd like, let's say you would like to take data from AMQP to Kafka or something like that, then Mutiny would be great. If it's about those stateful stateful logics, right, like joining data and aggregating, then I would say Kafka Streams is perfect for that, right? And I mean, there's so many things which we didn't discuss about it. So you can do interactive queries like going to Kafka Streams and just get the current data, let's say, for a given weather station. So this is really nice. And I'm really excited about the Quarkus extension also because it allows us to use this. I really would have liked to show the dev mode where you can get interactive feedback while you're working on this. Maybe another time. But then also you can run it on crawl VM. So yeah, I think Quarkus and Kafka Streams did really nicely. It's a nice combination.
Yeah, I like the fact that it does give you that kind of reactive programming, if you will, model from the perspective of online real-time streaming, but you get the real-time filtering and things like that in its own API that's very popular.
Right.
Now, one other thing I did notice, too, that you guys had the broker and the trigger in the Knative Eventing, right? And so that has come up in different presentations before, but I think you guys did a nice presentation of that. Now, there's that the reason you go to the broker and trigger is to allow for the filtering as opposed to the channel subscriber or just straight up eventing, source to sync. Could you tell a little bit more about the advantages of those different techniques, if you will?
Yeah, sure. If you go with the model of the channel and subscriber, like every event that is on the channel is going to all of the subscribers. Like every subscriber gets all of the events. And with the different approach from the broker and the trigger is really you have Knative broker as an eventing mesh there. So all of your different sources, and not just sources, like your Java backend application, for instance, that's running in the Kubernetes cluster, can talk to the broker and just publish an HTTP post request towards it, submitting cloud event compliant data. And then you have really this great opportunity that you can filter based on a few criteria of the metadata of the envelope of the actual cloud event. It doesn't do content-based scanning right now, but still it gives you a fine-grained way to actually route messages from different sources or different origins, if you want, to specific subscribers. So I think that is a really elegant way of having like a eventing mesh kind of setup scenario instead of just having the the subscriber and channel API. That said, behind the scenes, this infrastructure is being set up. So if you have a broker, it always has in the background running a channel and certainly subscriber for it, but the trigger mechanisms that are applied there. So the end user is really usually just interacting with a trigger and may also deploy a Knative serving service. And then you say, okay, filter XYZ enables me routing to this particular service. So that's really the bare minimum APIs that you have to work with.
Yeah, I think that's a very important point, right? The triggering and the filtering mechanism is based on the envelope, not the message contents, but the headers, if you will, the attributes associated with that message. So that's an important point. All right. Well, we are out of time. Well, there's one last question we'll try to get to real quick. When you decide to use WebSockets versus SSE for real-time visualization with data from Kafka, so when do you decide between WebSockets versus SSE?
Wow. I mean, so you're asking two backend developers about
right.
this front-end technology choice, right? So to be honest, I chose WebSockets there because it's the API I'm familiar with. I would suppose server-side events are equally usable or useful for that. So really, it was just a matter of my personal experience, I would say, and I think both would work.
Yeah, having worked with both, service and event would have been perfectly fine here because you just render the output. You don't have like any interactivity from the browser going back to the backend there. However, with the Java API and the standard there, and it's a very older API that is very mature, I agree. It's kind of the default choice there, but it's just personal taste.
And I'd say the same thing is for me, right? I default to WebSockets when SSE would do. Same reason. It's just easier, something you know. Okay. Yeah. Well, thank you so much. We are out of time for this session. We've got to go reset things to get ready for our next session. We'll be live streaming talking about GitOps here in a moment. But do remember to sign up for our future events. Check out those URLs we passed to you there. We also gave you the code base. And then if you want access to the slides, come back to that main registration URL a little bit later, and those will get uploaded if they're not uploaded already. I thank you all for your time. Matthias, Gunnar, awesome stuff. Great stuff.
All right. Thank you so much, Matthias.
Thanks for having us, Bert.
All right. Thank you.